Question 4, still on number patterns. Quadratic number patterns. But there's something unique on 4.1. So we explore in a moment. Check out the description box for more questions and waphendulile for this exemplar from 2023 November. So 4.1. You know, okay, but anyway, I said so. 4.1. In the diagram below, the first 3 figures in a pattern that Mary is investigating are shown. Figure 1. We have the first figure, figure 1, okay? They 4.1.1, they want us to find or determine the total number of squares in figure 5. So this is figure 1, figure 2, figure 3, okay? Then go to figure 4, no figure 5. They want us to find the number of squares. Figure number 5. Let's look at to figure 1. Silago 4.1.1. Let's look at to figure 1. F1, figure 1. How many squares are there? Only one square. Nasi square sakhona la. It's only this square. Figure number 2. Figure number 2. How many squares do they have? 1, 2, 3, 4 squares. So it's 4 squares. And then how about figure number 3? It's 1, 2, 3. 1, 2, 3. So 3 times 3, that's 9. Figure number 3, we have 9 squares. 6. Yeah, it's 9. It's 9. Okay. What about Uluganj, figure number 5? Let's start to go exam thinking, Mara, do I have to subtract? Let me try. 4 minus 1, 3. 9 minus 4, that's 5. What? Okay, I have common difference. If I subtract further, I'm getting a 2. But this doesn't mean Uguti, you actually have a quadratic. This is not confirmation Uguti, you have a quadratic number pattern. Ngabe bekune term yes 4, and then you differentiate, you find a difference, you get a value, then you find a difference again, you total out 2. Then you can say, okay, I have a second common difference. But this is not the case, man. No, it's not the case. It's not a linear, for sure. We're not sure which it's a quadratic number pattern, okay? But pegalama numbers closely. Just look at them closely. See, no 1, which is a perfect square. 4 is a perfect square. Singaipala is 2 raised to exponent 2. Then uloganji u9 we can write as 3 exponent 2. Figure number 1 raised to exponent 2. Singaipala. So anyway, 1 raised to any exponent is just 1. Okay, I'm putting u2 for convenience. What convenience? I see an exponent of 2, an exponent of 2 even here. So I'm thinking, why don't I put a 2? Okay, which makes sense, by the way. 2, it means that all of the numbers pattern here will be raised to an exponent of 2. 1 raised to exponent 2 because of its figure number 1. Figure number 2, it means that we're gonna have a base of 2 raised to exponent 2. Figure number 3, we are having a base of 3 raised to exponent 2. Then for figure 4, it means that for F4, we're just gonna have 4 raised to exponent 2, which is 16. Then go figure number 5, is just gonna be 5 raised to exponent 2, which is 25. 25. So the answer here to la figure 5 is actually what? 25. There will be 25 squares. 25 squares. Then for 4.1.2, how many dots will there be in figure number 7? again we count ama dots again manje. Instead of looking at ama squares, we just look at ama dots with. Alright, F1, figure number 1, how many dots do we have? 4. Figure number 2, how many dots do we have? 9. And then figure number 3, how many dots do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Okay, 16. Again, 4, 9, 16. What is this? Yini logu? Ama perfect squares again, right? Ilento bengikhuluma ngayo ngithi u4.1 there's something unique ngayo, ne? It's not like it's not the usual number patterns esiwajwayele ukuthi get the difference, go thola the next term, right? Lana you just have to apply your brain kancane nje, ne, to get the next terms. So lana I see a perfect square, 2 raised to exponent 2. I also see a perfect square, 3 raised to exponent 2. Another one, it's gonna be what? F1. Okay, anyway, then lana it's gonna be 4 raised to exponent 2. I think confirm 4 exponent 2, that's 16. Correct. Figure number 7, 2, 3, 4. Okay. I see where this is going. Uthatha u1 eta no1 uthola u2. Uthatha u2 eta no1, you get the 3. Uthatha u3 eta no1, you get this 4. Then you raise it to exponent 2. Okay, then go figure number 7. How many marks? 1 mark nyakanga. Examiner uyakanga. F7, it means that komele kuba ubani u7 plus the 1. We are following that pattern. Kuba u8 raised to exponent 2. I think u64, but let's confirm. 64. Okay, so go figure number 7 kuba ubani u64. Okay, about 64. Nice. Okay. 4.1.3. Consider the end figure. Show that an expression for the number of dots can be written as. Okay. Guess what? The new discovery yenzile la. The discovery yenzile, which you take this one, add to the take this one, add 1, you get the 2. 2 add 1, you get the 3. It actually validates this end term, right? So this is an end term of our dots, okay? It's the end term of our dots. But, to show through our calculations that this is true, we would have to get the end term basically, okay? But uma ngibhekile le end term le, the n plus 1 raised to exponent 2, it looks like a, yes, it looks like a what? A quadratic number pattern. Once you see a square nyana nje in a number pattern, just know that go to dilanani a quadratic. Even go 4.1.1, I am squaring. Guess what? This is what? Is a quadratic number pattern because of we are having a square lapha. Okay. I sense so. For this one, we would have to confirm or validate through a calculation. Okay, so guess just keep in mind ngidinga 4 yama terms la, ne? Just to see or witness or so that ngithola the second common difference basically. Things I'm going to show you. So figure 1, sina 4 dots. Figure number 2, how many dots do we have? 3, 9. Figure number 3, how many dots do we have? Sibale satolu 16. Then C10. Okay, for figure number 4, it's gonna be 4 plus 1 raised to exponent 2. It gives us ubani 25. I need this fourth term. Why? To confirm ukuthi vele kamarech is this a it is a quadratic number pattern. So 9 minus 4, that's 5. 16 minus 9 isn't it's yeah 7, and then 25 minus, I think it's 9. 9, yep, 9 minus lana, getting a 2, minus lana, I'm also getting a 2. This is confirmation which this is a quadratic number pattern. Okay, I need the 25 so that iphume 2 no 2, just to say, hey, bega say beg. This is a quadratic number pattern. Okay, nayo ke i-quadratic number pattern ethu sesiconfirmile ke manje. We can go ahead and calculate A wethu, B wethu, as well as ubani u-C. So A sizothi 2A is equal to 2, then A is equal to 1. Then B so 3A plus B is equal to 5. This 2 ubuyala. This 5 ngim equated to the 3A plus B. 3 A1 plus B, I don't know. Ek weet nie. 3 times 1, that's 3, plus B is equal to 5. B is equal to 5 minus 3. B is equal to 5 minus 3, that's 2. My B is equal to 2. Then siyobala ubani C is equal to 4. This 4 is coming from there, from that first term. So B 2 plus C is equal to 4. 1 plus 2, 3, plus C is equal to 4. Then C is equal to 4 minus 3. I'm transposing the 3 of figure about negative 3. Then my C is equal to 1. Okay, then siyabuya ke masithi alright. We substitute our A bethu, our ABCs on the standard form. Okay, so AN squared plus BN plus C. Alright, then you fagu A wam, B wam, C wam. Right? So I'm erasing this part so that ngizokwazi ukubhala kahle. Suga. Okay, now Tn uzoba equal to A ubani 1, so it's gonna be n squared plus B ubani konje 2, so it's 2n, and then C it's 1, so it's plus 1. This is a trinomial. You need to factorize this. Izokunikeza loku. So the Tn is equal to open bracket. I'm looking for is number as e2. Nangis multipliers inginikeza ubani u plus 1. It's either a minus 1 lana, and a minus 1. Of course, yoba n, right? But there's a problem. Lama factors lawa. Othi nawa multiplier akunikeza u positive 1. They should also give you a positive 2 when adding them. Minus 1, I negate minus 2, but it gives me what? I negate positive 2, but it gives me minus 2. So instead of having a minus 1, I'm gonna put a plus, right? Now this is correct. A plus 1 times a plus 1, negate plus 1. Plus 1 plus plus 1 plus 1 is actually 2n. Okay, so therefore Lama brackets combined, they are giving us n plus 1 raised to exponent 2. Raised to exponent 2. So this is our nth term. Now, so we just proved or validated the statement of a person. Okay, then 4.2. 4.2. An athlete runs along a straight road. His distance d from a fixed point P on the road is measured at different intervals. Okay. A distance d from a fixed point P on the road. Okay. And has the form dn is equal to this. is equal to this. Okay, so this guy or this athlete, I think, oh, okay, so T1, he is or she is 17 meters away from a destination point yakhe, right? 2 seconds later, he's now approaching it destination yakhe. So the distance, I'm thinking towards is that destination point yakhe, it's decreasing. That's why siba nama distances are decreasing instead of increasing, right? Then on the 3rd second, the distance is now okay, sega 5 meters away from its destination. 4 seconds later is now 2 meters away. I don't know, right? But one thing for sure, the distance it's decreasing because of is approaching any or she is approaching a destination point yakhe. 4.2.1, you determine the values of R and S. Check again, check. Kahle kahle this one ifuna ukuthi sithole u-R nalo bani nalo S. Yazi kunokubona abanye they skip this question, then baye kule following question, they get the end term like 4.2.2. They are basically saying find the end term yakho, get your a b c. Then after getting your ABCs, bese ke substitute the 5 and the 6, then they get their R and S. I have nothing against this, ne? Ungakenza lokho, but lana I'm gonna show you ukuthi ungayicalculate kanjani or R and S without the end term. So ni sino 17, sino 10, sino 5, sino 2, sino R, sibuye sibe nobani S. Let's check. This is check what's happening. Like 10 minus 17, that's negative 7. 5 minus 10, that's minus 5. 2 minus 5, that's negative 3. Negative 5, negative 7. Negative 5 minus negative 7, that's positive 2. Negative 3 minus negative 5, answer is 2. Okay, bheka, negative 2 plus negative 5 plus lo 5 athi ngikukhombe 5, this 5 plus negative 5, this negative 5 akusu 8 lo ngizomlungisa. It's not 8 plus negative 5 plus 2, I'm getting ubani 2. Let me fix this quickly. Sino minus 5 la, okay. Nangithatha this 5, this minus 5 and this 2, nangba add that they give me 2, which is the next term. So in order to ngithole this and this, I have to do the same now. Like ngithi 2 plus lo, this 2 plus this negative 3 plus this 2 zonginikeza the next term. So 2 plus negative 3 plus 2 is equal to 1, and then wena minus wena, I'm getting a minus 1. Subtract, I should get to 2. So negative wena plus wena, I should be getting ubani 2 la, ne? I should be getting a 2. Alright, but confirm again after sithole our end term like 4.2.2. Okay, determine the values of A, B, and C. So it's just a typical quadratic number pattern. Ne? Divide by 2, divide by 2. A is equal to 1. Sino 1 as A, then it's your 3A plus B is equal to that negative 7. 3 1 plus B is equal to negative 7. This negative 7. Then Sibano 3 plus B equal to minus 7. B is equal to minus 7 minus 3. Then B way to minus 10. Then siyaqhubeka, we are finding C through this formula. A 1, B minus 10 plus C equal to 17. siba no minus 9 plus c equal to 17. C is equal to 17 plus 9. C is equal to 6, 7, 8. Okay, so therefore we about 26 la. And term yet, okay, A, B, C. But I just told you A, B, C. Finish and klar. Finish and klar. Right? Finish and klar. I was about to tell you n term, but they said get you A, B, and C. Deal. Ne? But we would have to write down the n term so that this was will calculate to 4.2.3. Right? 4.2.3. 4.2.3. So D n is equal to A1. So it's 1n squared minus 10 minus 10 n plus what is C? C is equal to 26. Is equal to 26. So this is the answer. This is the n term. So what is the calculator? How far is the athlete from P when n is equal to 8? Let's see. Dn, okay, d8, distance at 8 seconds is equal to 1. 8 squared minus 10. 8 plus 26. Sithola ngayiki ke? It's gonna be a negative one la. A negative answer plus 26. Okay. 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 I see. Noma ngafaka bracket la. Uyazibuza umoya. Hey, we'll say a bracket. But is this true though? Okay, D8. This is what? It's 10 meters. Okay. Yeah, this is equal to 10 meters. Something is confusing me. Para. Okay, I answer it anyway. I answer it. But I'm thinking by this point, komele sekamdlulile point P. You know what? This is our answer. Okay, then for the last one. 4.2.4. Michaela claims that the pattern will have a minimum value. Jack claims that the pattern will not have a minimum value. Who is correct? So put your answer with an appropriate calculation. Okay. So the question then I'm going quite a lot my previous question papers, né? Where they ask you to get the minimum or a maximum value. I'm a quadratic formula. I'm a quadratic patterns. They are actually uma ngabe sothatha quadratic pattern plot on a Cartesian plane. You know sizothola iluganje parabola. We're actually gonna get a parabola now. Minus 10n plus 26. We're actually gonna get a parabola. If the A, also you know which the value that determines a shape your graph yakho, whether it's gonna be concave up or concave down, it's the A value. If the A is bigger than 0, it's gonna have a smiley graph or a concave up, meaning that ubane minimum. If your A is less than 0, you're gonna have a sad graph like this. Unani, you have a maximum. So this function actually, or this number pattern will actually have a minimum, right? Will actually have a minimum. So sizowenza kanje ke. We're actually gonna do this to prove. So zoti n is equal to minus b over 2a. Basically what into samukuyenza la ukuthola ini the turning point, right? N is equal to minus b ubani, the b is negative 10 divided by 2 a1. answer n is equal to 5. N wethu bani is equal to 5. So for the fact ukuthi n wakho is bigger than 5, it means that you actually have a minimum. You actually have a minimum. Okay. Wait. Minimum. You know what? I don't feel like there's a need for the turning point. I don't feel like there's a need. Or is there? Is there a need? What's happening, Mr. Pen? Alright, let's see what happens now having substitute at the n. About 5 squared minus 10, 5 plus 26. What's the answer? Squared minus 10 times 5 plus 26. 1. Okay. Right. Usakhumbula calculate r la nalo q. The r and the q, so sinobani sino 1. Lana we had 1, so I think rabe la. Go back to this. Nope. You no sla. Come on. Sila. So the answer is equal to bani 1. Lana we have a 1 and then a what? A 2. A 1 and a 2. So suga from 17, 10, 5, 2, 1. Then we go back to bani 2. This is further confirmation ukuthi actually 1 is in fact ilokanje ini minimum point yakho. Yabona? A minimum point yakho. So this actually confirms ukuthi kahle kahle Michaela is correct. Michaela is actually correct by saying ukuthi the graph will actually have what? A minimum. Alright? So but I also think that just stating logo and drawing lama curve lawa, I think it's enough. Alright, this concludes question 4 wethu on our quadratic number patterns. Thanks for tuning in. Ungakhohlwa ukulike, ukushare, nokusubscribe to the channel. Check out the description box for more content. As for me, ngizokubona on the next one. Sharp.